All right, welcome everybody. I'm Lucian Fogoros, and today we're talking about digitalization of the entire value chain in manufacturing. Our guest, Karsten, we're from Siemens. Welcome, Karsten. Can you introduce yourself and tell our audience your relationship with 3D printing?
Yeah, welcome. Thanks for having me, Lucian. Yeah, my name is Karsten Heuser. I'm heading and responsible for the additive manufacturing activities within Siemens Digital Industries. So I'm a physicist already a lot of years with Siemens. I already started to get in touch with 3D printing. I think this was 4 or 5 years ago, with my colleagues in Siemens Energy, where they pioneered the technology. And now for the last more than 3 years, I'm responsible for the software, the automation, and the digitalization business within Siemens.
Thank you for that introduction. Now, just maybe give us a little background about the decision making for Siemens to invest in additive manufacturing technology. Just take us back to the journey back 5 years ago.
Yeah, and if you take our slogan, which is transform the everyday. So what is additive manufacturing? At the end, additive manufacturing, it's sustainable. It's giving productivity for factories. It's improving product designs with less materials, so it's more performance with less material you need in that. It's revolutionizing spare part business. So if you look on, we are active in trains, we are active in energy, and our customers in automotive are active, and everybody has this challenge about spare parts, and all these kind of aspects are touched in this or that way with additive manufacturing. And therefore, I think it was a clear decision, and it's in the heart of our innovation power as a technology company within Siemens that we take ownership, we take leadership to transform this business, and as well help our customers to transform their business in additive manufacturing. And this is twofold in Siemens. On the one hand side, we have more than 200 printer in 45 locations. So we are using additive to improve our own factories, to improve our own products for sure. And then on the other side, the second fold is we're helping the customers to transform their business. It may be machine builder, where we help with automation and digitalization topics. It may be producer, service provider, tool maker, machine user in this bigger context. And there we help them to industrialize the technology, make it affordable, and bring it into an industry grade.
Thanks for that overview, Karsten. Now, I started my career building on my tool maker journey. So I spent 5 years in building molds. It takes probably 3 months. It was probably $250,000 to build a tool. Put things in context as to what a 3D printing might do to the industry that you've just referenced, in whether it's automotive or machine tool. How is that going to change, and how long will it take now to get a prototype?
Yeah, first, if you're in tool making industry, you know producing tools can be substituted by additive printed tools. So very often these kind of tools are very expensive. They are made out of milling processes, out of big metal pieces. And we just have developed a printing solution where we can free-form print such kind of molds with composite parts. So we teamed up with a robot company, we took the controller, and then you can produce a mold in a day, what you need some weeks before. It's much cheaper, it's much faster, you're more flexible. So this is the one aspect, is producing the mold itself for metal as well as for composite parts, really large parts for automotive. And the second aspect is, yes, as everybody knows, molds are very expensive. If you want to fast move into a market, you're looking into flexibility, you're looking in mass customization, and you need to produce molds for each and every different variant of a product. This costs you tons of dollars to produce this kind of molds. With additive, you can directly print these parts, and therefore there's a certain tipping point when you should further stay with your mold if you have 1 million parts everything the same. Injection molding will be the further choice in the future as well. But if you are looking into a very complex part, into fast delivery, into more stable demand supply chains, then additive should be your choice because you're much more flexible. And always in each application, you need to look on the business case, which is the best technology to utilize as well in the mold and die industry.
Thank you for that insight. And I remember going back, I mean, this is back in the early 90s. We were building molds for injection molds that would cost that much, like I mentioned, $250,000. But also the penalty for not finishing on time was just as much as the tool itself, for every day late, because it was aircraft and so on. So it's time to market. It's the cost effectiveness of using such tool. Now, I've also just recently watched something on more that everybody has in their home. So the personal footwear. So I watched the videos on this. Give us some insights. What does it do to the future of manufacturing, supply chain, and the future of retail, per se?
Yeah, this is a cool one, a pretty cool one we just launched and we introduced. And this goes in the direction of a very high flexibility in midsole shoe production. Just before I start into the use case, I need to tell I'm wearing additive produced shoes now for more than 1 year, but unfortunately it's not individualized, it's not performing according to my needs, especially they all have the same color. And yes, it's possible, but this was something, a different approach we took here. So we teamed up with machine builder like EOS, like Dimension, like others in the full process chain from end to end. And then we asked two of very high talented shoe designer to come up with a fully free design for a next generation shoe. This was a pretty complex one, which is a combination of different kind of lattice structures with an algorithms behind. But we took the challenge of these two gentlemen, and then we started the project in the last 6 to 8 weeks. How would a real serial factory look like to produce 100,000 pairs of these midsoles in more than 1,200 variants? So it's different colors, different hardness, different sizes. And normally it's randomly distributed. You don't know when people like which color in which shop. So in this regard, the flexibility of the factory was of utmost importance. And then we teamed up as well, that you may know, we have in Siemens factory planning consultants. They started with one of our own software tool to plan a full factory. And it consists of, for example, 11 of the latest printer from EOS and some of the coloring and surface finishing stations from Dimension and others. And this kind of factory was not optimized on the shop floor. It was optimized as a digital twin. So we fully optimized the factory and the worker you need, the machines, the gas, everything. This was fully optimized as a digital twin. And then we realized as well this factory as an extension of our experience center. And we for sure proved with the first prototypes that the concept is working. And with that, at the end, it's about pure productivity. It's about affordable production. It's about having an integrated workflow with efficiency to make it scalable at the end of the day.
Great insights there. Sounds like just about any industry could benefit from it, or not just from 3D printing, but also the disruption that comes with digitalization as well, that you reference a little bit with digital twin and so on. So I want to close with some question, with some words of wisdom for some of our listeners out there that are considering additive manufacturing in their facilities. How do you get started, and perhaps what are some of the things to watch out for, some of the suggestions there?
That's a very good question, because we get this very often by the visitor in our additive manufacturing experience center. How to start? Some purchase a machine and then try to find an application. Others put a 10-year strategy project in place to look, what is my perfect plan? I can tell you this is the wrong approach into it. And what always is my suggestion and my advice to the companies is, form a team of experts who are willing to disrupt your business. Get them connected into the ecosystem. Don't invent the wheel once more. So there are platforms, there are communities where they can be educated, and then try to start small, have a commitment from your CEO, small into your business, and then in a very agile, rapid learning process, find your first applications. You may start with a spare part, or you may start with optimizing them pieces in the factory, which is a small number of parts. You don't need to have printers in the first week. So let's see and find out which direction, which application, which material, but invest into your people, invest into the design capabilities, give them tools at hand, which helps them to leverage the possibilities. So it's nonsense to print a part equally designed what you can do by other technologies. You need to learn how to rethink the design of the product. So, and with this team, then in a very agile manner, you can experimentally learn and step yourself forward, and then you will automatically grow and come into a next phase where you will identify more parts and larger quantities, and you may end up in serial production at the end for your company.
Karsten, thank you for the insights into digitalization of the entire value chain in manufacturing. And if you're out there watching this video, engage with the subject matter experts from Siemens, whether it's Karsten or his team there.